Hi everybody, Mrs. Bolin here, and we're going to take a look at Learning Target 6.2. I can apply exponent properties involving products and quotients. If we take a look at some of the problems today, you'll see that we have a variable raised to an exponent or a variable raised to a power. Sometimes there's multiple variables in the problem, and these variables are being raised to a power. And there's a couple rules that will help us to be able to simplify. So one of these rules is the product rule, and product means multiplication. So a generic rule that we could write is, let's say you have a raised to the m power times the same base, a raised to the n power. Then our base would stay a, and here with our exponents, we would add the two exponents. So it would be a to the m plus n. Might seem a little funny writing it generic like this with letters, so maybe a more helpful example would be to use some numbers. So let's say we had x to the 6th power times x. So notice they have the same base x, and so for that reason, we will continue with the base x, and we will add the exponents. So here I have x raised to the 6th power, and here I have just an x. Anytime you have just an x, this is like saying x to the 1st power. So we would have 6 plus 1, or x to the 7th power. The quotient rule is going to be just the opposite. Product rule dealt with multiplication of like bases, and so we added the exponents. Now with quotient rule, we're going to have division of like bases. So that would be like saying a to the m power divided by a to the n power. And with the quotient rule, when you're doing division here, instead of adding the exponents, we will subtract the exponents. So it would be a to the m minus n. Maybe an example with some numbers here will make some more sense. Maybe we have x to the 15th power over x to the 8th power. So to simplify here, because both of our bases are alike, they're both x's. Here we see that we have the quotient rule, so we'll do 15 minus 8, and we'll get x to the 7th. The last rule here, it's called 0 power, and this is when you have a base raised to the 0 power. And this is an interesting rule because anything raised to the 0 power equals 1. No matter what. Doesn't matter what your base is, if it's raised to the 0 power, it's going to equal 1. So an example of that, let's use maybe two different variables for this problem. Let's say we had something like x squared. Now I'm going to use a different variable, y to the 0 power. Well, this y to the 0 power will just become 1. So you would be doing x squared times 1, or you would just get x squared. We will see this y to the 0 power, or this base to a 0 power, over and over, and you'll notice that it drops out of the problem because you're simply multiplying by the number 1. Let's go ahead and start by applying the product rule. So our directions tell us to simplify that our answer should contain only positive exponents. So what that means is I can't have something like x raised to the negative 2nd power. That would not be allowed. So only positive exponents here. So on example 1, I have x to the 3rd power times negative 3 times x to the 4th power. The first thing you have to do is look at any coefficients, and that word coefficient means any of the numbers that are out front. Here we have two different terms being multiplied. We have our multiplication sign, and the coefficients have to be multiplied. So for my first term, I don't see any number out front, so that's like saying there's a number 1 there. But in my second term, I see the number 3, so I do need to pull that negative 3 out front, and then I can apply my product rule. So notice that these have the same base. They both have base x, x to the 3rd and x to the 4th. So what I can do is keep the base, and I will add the exponents. 3 plus 4 gives me 7. And there would be my final answer. Let's look at example 2. In example 2, I first have to take a look. I've got two terms, right? I have one multiplication sign here, and I have to look at the coefficients or the numbers that we see out front. I see a 2 and I see a negative. This is like saying a -1. 2 times -1 will give me -2. And now I can begin to look at like bases. So I see I have a v squared and a v to the third. So I can simplify like bases. I'll keep the v squared times v to the third. My product rule tells me I add the exponents. 2 plus 3 gives me v to the 5. And then notice I still have this u to the third power here. That didn't drop out of the problem. I still have u to the third. So that needs to also be a part of my answer, u to the third. All right, in example 3, first I've got to look for any coefficients that I see. I have a 3 and looks like I have another negative. So this is like saying -1. 3 times -1 gives me -3. Again, pointing out we've got two terms being multiplied with the product rule here. And let's start to look at our like terms. So I see I have a p to the third and a p. If you just have a variable, that's like saying p to the first power. So I will keep my base as p. P to the third times p to the first. I'm going to add the exponents. 3 plus 1. So I'll have p to the fourth power. I can move on to my next term. Let's see, I've got q to the fourth power, and looks like just a q. If I just have a q, that's like saying q to the first power. So I'll keep my base, like base of q. Q to the fourth power times q to the first power. Product rule tells me I have to add my exponents. 4 plus 1, I'll get q to the fifth power. And lastly, I see that I have some, a third variable here, some r's. So I have r squared, and I also have r to the 0. We said anything raised to the 0 power is just 1. So you can almost like put a slash through that. So we just have an r squared here that needs to be in our problem. Another way you could think of it is if you didn't notice that something raised to the 0 power is just 1. 2 plus 0 is just 2. So again, that works out too if you didn't notice that. But anything raised to the 0 power, that's our 0 power rule, it's just going to be the number 1. Let's do one more example. Example 4, multiply your coefficients or the numbers out front. Again, I've got two terms being multiplied here. -2 times 3 will give me a -6. And then I usually just go in order. I see I've got an x term times an x term. So that's like saying x to the first power times x to the first power. So like terms, keep my base. X to the first times x to the first, I add the exponents. 1 plus 1 gives me 2. So I'll have x squared. Next up, I see I've got z and a z cubed. So this is like saying z to the first power times z to the third power. 1 plus 3 will give me z to the fourth power. And then lastly, I have some y's in the problem. I have y to the third and y to the fourth. So I will keep my base as y. 3 plus 4 gives me 7. The order that you're listing these variables here does not so much matter. I often just kind of go in the order that I see them in the problem. So keep that in mind if you had this mixed around. If let's say you had -6 x squared, y to the 7th, and then you listed z to the 4. If you were kind of going x, then y, then z, that's totally fine. The order that you're listing your variables here does not matter. You just have to be very careful when you're simplifying to see what exponents you get. At this time, you have 4 different u tries to do. So you can go ahead, pause the video, and see what you come up with. Let's see how you did. So on the first u try, you had to be careful. Notice that we did have x raised to the 0 power, so this was a 0 power rule. In other words, this would turn to the number 1. Anything to the 0 power is 1. So you're essentially doing -2 times 1 here. Anything times 1 is just itself. So I often like to put a slash through it because anything times 1 is just itself, or you can think of it as dropping out of the problem. So on the first U try, I had 2x. Second U try, I had 2m to the 5th, n to the 7th. Third U try, I had another 0 power rule there. So I ended up with 6, a to the 3rd, b squared, c to the 4th. And on the last U try, I had -8, x to the 5th, z to the 6th, y to the 3rd, being careful of yet another 0 power rule there. So we've practiced with the product rule. Now let's flip to the back and take a look at the quotient rule. So we said the quotient rule is the exact opposite of our product rule. So with product rule, we were multiplying like bases and we were adding the exponents. So now for quotient rule, we'll be dividing the like bases, and so we subtract the exponents. I'm going to make a little note here, which may be helpful. So we said that we are going to subtract like bases. What I mean is we're looking at the exponents and we'll be subtracting them. And often I have students question, once I do the subtraction, where do I keep the exponent? Do I keep it in the top? Do I keep it in the bottom? Because again, with quotient rule, if you look at example 5, these are fractions, right? This is a quotient. So we're going to subtract like bases, and I'm going to say, and keep the exponent where the bigger exponent was. Keep exponent where the bigger exponent was. So again, we can only subtract like bases, and then you're going to have to decide once you're left, once you do your subtraction, you're going to keep that exponent where the bigger exponent was. So if we take a look at example 5, our directions say to simplify and that our answer should contain only positive exponents. So I know that I'm going to have a fraction, so I like to often start by writing my fraction bar. Just like with the product rule, we have to start by looking at the coefficients that are out front, or the numbers that we may see. So I notice in the top I have a 2, and in the bottom I see no coefficients, so that's like saying that there's a 1 there. So 2 divided by 1 is just going to give me 2, so I'm still going to have a 2 in the top of my fraction. Now I can move on to start to look at like bases. So I see, let's see, in the bottom, I have just a p by itself. So that p is going to stay by itself in the bottom. I notice I have m's in top and bottom. I have m to the 3rd and m to the 4th power. So because these have a like base of m, I can subtract the exponents. So what's the difference between 4 and 3? 4 minus 3 is 1. And I will keep that m to the 1 where the bigger exponent was, or in this case, where m to the 4 was. So again, 4 minus 3 is 1, so I have m to the 1. And you have to decide, should you keep the m to the 1 in the top of the fraction or in the bottom of the fraction? We said we're going to keep the m to the 1 where the bigger exponent was, and here it was in the bottom, so we'll keep m to the 1 in the bottom. You can write m to the 1, but I'm just going to write m because, again, if there's no number 1 there, that's implied. That's m to the 1st power. Now I need to combine my q's. I have q to the 4 in the top, q to the 3rd in the bottom. So I can subtract here. 4 minus 3 is 1. So I have q to the 1st power, and I have to keep it where the bigger exponent was, or in the top. I could write q to the 1, but I'm just, again, going to write q. So here would be my final answer. I've taken care of everything. I've taken care of each variable. Let's jump to example 6. So in example 6, I'm going to write my fraction bar. And in the top, I would have a coefficient of just 1. In the bottom, I would have a -1. So here, 1 over 1 is just 1. And I'm left with a -1, right? 1 over -1 is -1. I can choose if I want to put this negative sign in the bottom. For me, I'm just actually going to pull the negative sign out front. And this is common with fractions. When you have a negative fraction, you can choose if you want to keep it in the top, the bottom, or commonly you'll see it pulled out front. So now let's start to combine. So I've got m squared and m to the 4th. So those would be like bases, m and m. So I will subtract the exponents. 4 minus 2 is 2, and I'll keep it where the bigger exponent was. So I'll have m squared in the bottom. Now I can look at my p's, and I actually see that in the top I have p to the 0. So that's our 0 power rule. Anything raised to the 0 power is going to give us the number 1. Anything times 1 is just itself. So you can think of it as it's dropping out of the problem there. So really I just have p to the 3rd in the bottom still. If you did not notice the 0 power rule, no big deal. If you tried to do your subtraction here with the like base as p, and we did 3 minus 0, we would still get 3, p to the 3, and you'd notice you still have p to the 3 in the bottom. Lastly, I've got q squared over q squared, or I have the same thing on top and bottom here. This is like saying 5 divided by 5. Anytime you have like a number divided by itself, or in this case, we've got a variable divided by the same variable, it's going to cancel out of the problem, right? And so this would just become the number 1, and it's silly to write times 1 because we've already said anything times 1 is just itself. If you didn't notice that my q squared and my q squared drop out, you could have done subtraction. 2 minus 2 is 0, and you would have q raised to the 0 power, and we said anything raised to the 0 power is just 1. So again, that's dropped out. So here's what I'm left with. The only issue is I can't just leave the top empty like this. This is a fraction. Your answer is not just m squared p to the 3rd. This is in the bottom of the fraction. So I do need to put the number 1 as a placeholder in the top. And from the very beginning, we said there is the coefficient 1 there, right? You don't always have to write your coefficient when it's a number 1. So this would be our final answer. You could put this negative sign in the top with the 1. You could also put this negative sign out front here in the bottom. It's up to you. I just pulled the negative sign out front because overall it's a negative fraction. It's not going to matter where you put the negative sign. All right, so at this time you have 4 U-tries. Go ahead, pause the video and see what you come up with. Let's see how you did. On the first U-try, I ended up with 1 over 3p. On the second U-try, notice 4 over 4 dropped out, and also I had a 0 power here. So I have v over u to the 4th. My third U-try, b over b canceled out. I ended up with a to the 4th times c divided by 2. And then on my very last U-try, I pulled the negative sign out front, but again, you could have kept this negative sign in the bottom with the 3. That would be totally fine. Negative 2/3 in the top. I've got 2xz, and in the bottom, I had 3y. Notice here we had another 0 power. So last section of our notes, we did just the product rule and then just the quotient rule. Now we're going to do both of them together. So when we're applying both the product and the quotient rule, I'll make a note here for us that we should first apply the product rule. First apply product rule. And then once we apply the product rule, I'm going to say second, apply quotient rule. And I like to do this in 2 completely different steps to be sure I'm doing it correctly. So first I'll do the product rule with multiplication of like bases, and then I'll apply the quotient rule with division of like bases. On example 7, our directions say to simplify and that our answer should contain only positive exponents. So I first need to do product rule. You'll notice there are both product and quotient rule taking place. I can see the quotient rule right away, right? I have the fraction bar, and my product rule is taking place here in the bottom. I have 2 terms being multiplied. So that's the part I'm going to do first, the product rule. I have a term times a term. My top, I'll leave exactly the same. I'm not going to touch that yet. I have no product rule in the top. So I'm going to leave this as negative v squared, or you can think of that if it's helpful as negative 1v squared. So I'm going to write negative 1v squared in the top. I'll write my fraction bar, and now I'm going to do product rule in the bottom. So in the bottom, first I'll take care of my coefficients out front. Negative 3 times 2 gives me negative 6. Now I got to start combining like bases. I see u to the third and u to the fourth, like bases being multiplied, so I can add the exponents. 3 plus 4 will give me u to the seventh, and then I see that I have v to the third times v squared. I'll add my exponents. 3 plus 2 will give me v to the fifth power. So what I did in this step is I applied the product rule here in the bottom of my fraction. So now I have no more product rule, but notice I have quotient rule. I have my division bar here. I've got a fraction. So let's look at the coefficients out front. -1 divided by -6 gives me 1/6. I see that I only have a u in the bottom here, just a u to the 7 in the bottom, so that's going to stay in the bottom, u to the 7. And then I can combine my like bases here, my v's. I have v squared and v to the fifth. So quotient rule, right? Division is taking place. So I will subtract the exponents and I will keep it where the bigger exponent was. So I'll keep it in the bottom. So 5 minus 2 is 3. So I'm going to keep it in the bottom. So I'll have v to the third in the bottom. And then here would be my final answer after I have applied both the product and the quotient rule. Let's look at example 8. So on example 8, notice in this problem we can see the quotient rule. That's very obvious with our fraction bar, but we have product rule in the top and in the bottom. So I'm going to start off by writing my fraction bar, and let's first do the product rule just in the top. So I've got a term times a term. So I have no coefficient in my first term. That's like saying 1. So 1 times 2 is 2. Now let's look at the bases. I see that I have u squared and u to the third. So u squared times u to the third. Product rule, I will add my exponents. 2 plus 3 gives me 5. So 2u to the fifth. I'm still left over with this v to the third. So I have to add in the v to the third in the top. Now I can move on to the bottom and I can do my product rule in the bottom. So I have a term times a term. 1 times -1 gives me -1. And I see that I have, let's see, v times v times v, or that's like saying v to the first power times v to the first power. That will give me v squared. And then I've got this u squared by itself. All right, so I applied the product rule on the top, the product rule in the bottom. So no more product rule, right? There's no more multiplication signs. Now I need to do quotient rule. So 2 divided by -1, that's going to give me -2. You could also pull the negative out front, that's fine. Or even if you want to write it -2/1, that's fine. All right, now let's combine. I have u to the fifth power over u squared. So I need to subtract the exponents if they are like bases. 5 minus 2 is 3, and it's going to stay where the bigger exponent was, so u to the third will stay in the top. I also need to look at the v's. So 3 minus 2 is 1. I'll have v to the 1, and it's going to stay where the bigger exponent was, or it will stay in the top. The only thing I would say about this is it's kind of silly to write divided by 1. So I would just simplify it to say -2 u to the third v, and we don't need to write it as a fraction because, again, it's silly to write divide by 1. So my final answer here equals -2 u to the third v. Alrighty, you have the very last 2 u tries. You'll first have to apply the product rule, so notice where you have multiplication taking place, and then lastly apply the quotient rule. Go ahead, pause the video, and see what you come up with. On the first u try, I first applied the product rule. Be careful, I noticed I had a 0 power rule here. Once I applied the product rule, then I could apply the quotient rule. I ended up with r divided by 6. And on my very last u try, I first applied the product rule here, and then I applied the quotient rule, Notice right here I did simplify 4 over 6. That's a fraction that can definitely be reduced. So 4 over 6 simplifies to 2 over 3. So I have 2y squared divided by 3xz.